Now see, there are the two charges, one is 0.2 into 10 raised to power minus 12 coulomb, another one is minus 0.2 into 10 raised to power minus 12 coulomb. So, this is actually an dipole, an electric dipole. Both these charges are separated by a distance of 10 raised to power minus 6 centimeter. So, we can write 2a is equal to distance between the two charges 10 raised to power minus 6 centimeter is equal to 10 raised to power minus 8 meter. Now, this is the middle point here. From the middle, you have to calculate electric field intensity at a distance of 10 centimeter. So, we can take r is equal to 10 centimeter, that is 0.1 meter. So, we have to calculate electric field at any point on the axial line. So, we have already calculated the formula for that. E is equal to twice of P divided by 4 pi epsilon naught r cube if 2a is much less than r. This condition is applicable here. So, we can use this formula, this is r cube. So, we can use this formula here. So, we can write E is equal to twice of P, we can write Q into 2a. The Q is equal to here 0.2 into 10 raised to power minus 12 into 10 raised to power minus 8, that is here P is equal to Q into 2a divided by, here also 1 upon 4 pi epsilon naught, we can write 9 into 10 raised to power 9 divided by r cube. So, 0.1 cube. When we solve all these things, you will be getting 3.6 into 10 raised to power minus 8 Newton per coulomb. So, this is the electric field intensity at a point on the axial line from the middle at a distance of 10 centimeter.